So we continue with the same problem. So first step is to find a number of poles and zeros. Okay, so there are 3 poles. So second step is to find the root locus on real axis. So that is my second step. So there is only one pole on the real axis at the origin. Okay, that is 0. Hence, if we choose any test point on the negative real axis, then to the right of that point, the total number of real poles and zeros is 1, which is an odd number. Hence, the entire negative real axis will be part of root locus. Hence, the entire negative real axis will be part of root locus. Negative real axis will be the part of root locus. So, root locus lies on the left side of real axis. Root locus and the real axis shown. Okay, so see this picture in S plane. This is a positive real axis, negative real axis, positive imaginary axis, negative imaginary axis. So these are the poles P1, P2, P3 marked here. Okay, then next step is we have to calculate the angle of asymptotes and the centroid, right? Right. So, what is my centroid formula? Sum of poles minus sum of zeros divided by n minus n. So, sum of poles minus zeros are 0, n minus n is 3. So, it is minus 1.33. So, the centroid, the point is here. At this point, the centroid lies at minus 1.33. Then, to find the angle of asymptotes, so what is my formula? Plus or minus 180 into 2p plus 1 divided by n minus n. Okay, right. So for n minus m, so n is 3, m is 0. So the q values are starting from 0, 1, 2, 3. Right. For 1 second. So when q equals q, the value of q is from 0 to 3, 0 to n, right? So when q equals 0, we are getting angle plus or minus 60, q equals 1, 180 degree, q equals 2, it is 360 degree. If it is 360 degree, we have to subtract it from 300. We have to subtract it from 360, we get 60 degree. q equals 3 is, again we get 420, we have to subtract it from 360, we get 60 degree. So plus or minus 60 degree and 180 degree. So we can write the angle of asymptotes. We have to draw the angle of asymptotes from this point. So plus 60 degree one asymptote, minus 60 degree one asymptote. So there are two asymptotes. There are two asymptotes. Plus 60 and minus 60 degree. Right. The point is minus 1.33. Then 180 degree is on the real axis. Okay. Then what is my step 4? Step 4 is to find the breakaway and break-even points. For that, the closed-loop transfer function, we have to determine g of s will be 1 plus g of s. We put here it is an unity feedback system. So we get k divided by s into s squared plus 4s plus 13 plus k. Right. So now we equate this characteristic equation, denominator polynomial equals 0. So in that case, k equals minus s cube minus 4 square minus 13s. So you have to differentiate this equation with respect to s. It's minus 3s squared plus 8s plus 13. So put this equals 0. Okay, dk by ds equals 0. We get 3s squared plus 8s plus 13 equals 0. So what is my s? S equals minus v plus or minus root of v square minus 4ac by 2a. You get minus 1.33 plus or minus j 1.6. Right. So this is my yes. So for s equals this value, what is the value of k? Substitute for s, substitute this value and calculate the value. So it is positive and real. So we shown that when s equals minus, when s equals to plus one value, minus one value, k is not equal to real and positive. Since the values of k for s equals 1.33 plus or minus j 1.66 are not real and positive. So this is also not real and positive. These points are not an actual breakaway or break-even points. The root locus neither has neither breakaway nor break-in points. So it is not an positive and real value. So there is no break-even and break-in points. Next is to calculate the angle of a departure. So angle of departure, the formula is 180 minus tan inverse of 3 by 2. So here for this pole number 2, height is 3, width is 2. So 3 by 2. So this is 123.7 degree. For theta 2, so this is for theta 2, it makes angle 90 degrees. So 90 degree. So what is angle of departure from pole P2 is 180 minus theta 1 plus theta 2. That is minus 33.7. So minus 33.7. Right. Then angle of departure from P3, P2 is minus 33.7. P3 is plus 33.7. P3 is plus 33. This is minus 33. So you have to draw. We know that. So to find the crossing points, this is a characteristic equation. We solve it. The W value is plus or minus 3.6. K value is 52. So we can draw starting from pole 1 minus 33. From pole 3 again 33. It starts here and it intersects 3.6. Positive imaginary axis 3.6, negative imaginary axis 3.6. We join this, we get a beautiful root locus. Okay. Thanks for watching. We discuss another example in my next class.